Hi friend, today we'll discuss the square wave waveform and how to find the given parameters. So for this kind of waveform, this is the square wave and the RMS value of this square wave can be calculated as the given value from this. It is I naught is equal to, this is a 10 ampere. So it is given 10 ampere. So I naught is given 10 ampere and here we have to find the IRMS. So IRMS, we are going to find the first value, RMS value of the current. IRMS is equal to I naught into square root of omega by pi. So omega is the pulse width in the radian. So this is a pulse width, total pulse width in the radian. So here omega is pulse width and this is in radian. Therefore we have to substitute omega is equal to 180 degree or it is a pi radian. Okay, so if you substitute here 180 degree, then we'll get here the values. I naught is here 10 ampere and this is a 180 degree by 180 degree. So what value we are getting here? We are getting here 10. So IRMS is there 10 ampere. Okay, so we have to again find the fundamental component of current. So the fundamental component of current is calculated like this. For a square wave, this is a square wave, this is a square wave, and for the square wave the fundamental component is calculated, that is by this formula. I1 is equal to 2 root 2 by pi into I naught. So here we have to calculate like this. So this is 2 root 2 by pi into 10. So we'll get here 9 ampere. So this is the fundamental component of the current. We have got the second. Now the Crest factor. Crest factor CF. How to calculate the Crest factor? Crest factor is calculated. This is the formula for the Crest factor. Crest factor is equal to I peak divided by IRMS. So I peak, we know that here peak value of the current is given and IRMS value of the current. For a square waveform, this is a square waveform, and for the square waveform the current is given 10 ampere. So therefore here I peak and IRMS, they are equal, and this is equal to I naught, and therefore I naught is given 10 ampere. Therefore the Crest factor is equal to 10 ampere by 10 ampere is equal to 1. So we have got here Crest factor is equal to 1. Now the last is the Crest factor we have got. Now the distortion factor. Distortion factor, that is a DO. Distortion factor is equal to the fundamental component of the current divided by the IRMS. So the fundamental component of current we have got here 9 ampere. So here 9 by RMS value, we know this is a 10 ampere. So this is a 0.9. So the distortion factor is 0.9. Now we'll go for the last value, that is a fifth value, that is a percentage total harmonic distortion. Percentage total harmonic distortion can be calculated by this formula, square root of 1 over distortion factor whole square minus 1, and to multiply it by 100. So if you put these values here, distortion factor we know is a 0.9, 0.1 by 0.9 whole square minus 1 into 1000, and if you calculate this value, will get 48.34%. So in this way we can find the different parameter for the given square wave. So it depends upon whether the wave is square wave or the quasi square wave. So here we have found the different parameters for the square wave. In next examples we will discuss a quasi square wave. Quasi square wave where the pulse width is not equal to 180 degree. It is less than by the 180 degree. Thank you very much. We will discuss in the next example.